chat box. Now let's begin the session. Now you can start your session.
Good afternoon, everyone. Good afternoon. Can you hear me?
Yes, ma'am.
Am I audible to everyone?
Yes, ma'am, you are audible.
Okay. Okay, thank you. So, good afternoon, everyone. First of all, thank you all for joining and thank you for the warm welcome. It was actually very nice. So, over the next 60 minutes, we will be exploring some basic concepts of arson investigation. And by the end of the session, you will get a basic understanding of basics of arson and the investigation process. So, let's get started. Let me share my screen.
Yes, ma'am, I have already given the permission.
Can you see my PPT slide?
Yes, ma'am.
Yes, ma'am.
Okay, okay, fine. So let's start it. So my topic is fire investigation or arson investigation, an introduction to arson and its investigation. So we all know about different types of fire. There are different kinds like natural fire, accidental fire, and arson. And there are some differences between these three. So the first one is natural fire. So natural fire is actually caused by some natural process like lightning. The usual cause of natural fire is lightning or any kind of spontaneous combustion of dry fuels such as sawdust and leaves like that. So materials like coal, hay, oily rags also can undergo spontaneous combustion and they are susceptible to burn. And the next is accidental fire. And accidental fires are those in which the proven cause does not involve any deliberate human act to ignite or to spread the fire. And there are some sources that are susceptible for burning. It may be caused by discarded burning cigarette ends or matchsticks or short circuiting and defective insulation. There are a various number of causes for an accidental fire scene. Or some more examples are heating appliances or any sparks produced by friction in factories like that. So, as I have already mentioned, natural fire is caused by natural means like lightning, etc., or spontaneous ignition of oily rags, sawdust, like that. And accidental fire is caused by accidental means like overloading or jury rigging or any kind of unsafe burning practices or welding practices like that. So these are natural and accidental fire. And the third one is arson. There are some basic elements or core elements which distinguish arson from these two kinds of fire scenes, that is natural and accidental fire scene. Natural and accidental is different from an arson scene. So, what is arson? Arson is the act of intentionally or maliciously destroying or damaging a property through the use of fire. So, it is an act that is caused intentionally and maliciously, that is destroying or damaging a property through the use of fire. So, within this definition, we can see there are four core elements for arson. that is for a scene or a fire scene to be considered as arson, there should be four elements, and that four elements are listed here. The first one is lighting of fire. So we know that fire is the fundamental of arson. If there is no fire lit, then there is no arson. So fire is the fundamental element. There should be burning. There should be burning of something. Then only it can be considered as a arson scene. Next one is intention or willfulness. So there should be intention or willfulness for setting out the fire. And this element or this core element excludes all other fires which have a natural or accidental cause. And the third element is malice. That I have already mentioned that the intention should be malicious. So the intention to start the fire should be malicious or malice intention should be there. And this excludes all other fire which was set out with a positive or legitimate intent. We know that some of the accidental fire or the fire which was set by human beings may have a legitimate or positive intention, or we may get some positive outcome. But in arson, the intention to start the fire is always malicious, to damage or to cause destruction to a property. And the fourth point is object. There should be burning of any kind of property or object. So these are the four core elements of arson. First one, lighting of fire, then intention or willfulness, third one, malice, and object. So if for a fire scene to be considered as arson, these four elements should be there. So, what makes a person an arsonist? So, there are some motives which make a person an arsonist. Actually, there are different motives, but some of the motives are I have mentioned here. The first one is crime concealment. So, most of the criminals use arson as a means for conceal the evidences of illegal activities or other crimes. So, one motive can be crime concealment. The next one is financial gain, like insurance claim. For that purpose, some may cause arson. Then the next one is revenge, vanity, or any kind of psychiatric afflictions like pyromania, like that, or any kind of delinquent behavior. So these all are examples for motives which make a person an arsonist. Now, what is the importance of investigating an arson scene? We know that fire has tremendous potential, or it has a great potential to destroy property and life. It is capable of destroy everything. Okay, so fire is potential of destroying everything, and fire itself destroys most of the evidences which are present at the crime scene. So, if in a crime scene fire is present, it has the potency to destroy the other evidences which are present at the crime scene. Then the efforts to extinguish the fire may destroy or contaminate the other evidences present. So, during the efforts, or when a person or a firefighting official is trying to extinguish the fire, there is a chance for destroying or contaminating the other evidences which are present in the crime scene. So, we have to meticulously, or we have to investigate an arson scene with tremendous importance. And some criminals may use fire to destroy the evidences of illegal activities. So, due to these reasons, we have to give utmost care when we are investigating an arson scene. So, actually, an arson investigation isn't just finding who is the culprit. Actually, it's uncovering the truth which is hidden in the ashes. So, these are the importance, or these points gives us the importance of investigating an arson scene. So before going into investigation process, a person or the investigator should have a basic idea about what is fire, or the chemistry and physics of fire. So first of all, discuss about it. Fire. So it is a rapid, self-sustaining, exothermic oxidation process which is accompanied by the evolution of heat, light and flame in various intensities. Fundamental elements of fire. There are three fundamental elements of fire which makes a fire triangle. The first one is fuel, next is input heat and oxygen. These three elements make a fire triangle. So now let's discuss in detail about these all elements. The first one is fuel. So fuel can be any combustible material in any state of matter. That is, it can be a solid, liquid or gas. So first you have to keep in mind that solid and liquid cannot burn by themselves. They have to be converted into gaseous state for burning. So can be any material, solid, liquid, or gases, but solids and liquid to be should be converted to gaseous form to burn them. So examples for solid fuels are wood, plastic, paper, coal, like that. And for liquid, it may be gasoline, kerosene, alcohol, varnish, or gaseous fuels are natural gas, carbon monoxide, butane, hydrogen, like that. And next one is input heat. Input heat actually is the energy we are applying or we are giving energy in the form of input heat. So as I have already mentioned, solid and liquid materials do not burn by themselves. For combustion to take place, these materials, that is solid and liquids, should be burned to produce vapors. So actually it is these vapors that will burn. And there is an important concept, or there is a certain temperature called as ignition temperature. And the ignition temperature is the temperature at which the vapors will ignite. So actually the input heat or the heat sources helps to reach the ignition temperature. There are different kinds of heat sources available. It may be any kind of cooking equipments like toasters or oven, like that, or iron. Okay, so the purpose of heat sources is to helping the vapors or the fuels to reach their ignition temperature. Open flame, friction, hot surfaces are examples for input heat. The next one is oxygen. The primary source of oxygen is atmosphere itself. Actually, our atmosphere contains approximately 20.8 percentage of oxygen, but a concentration of about 15 to 16 is needed for the continuation of a flaming combustion. But we can add some external substances or external agents which are called as oxidizers, which can act as primary or secondary sources. Okay, so actually primary source of oxygen for burning is atmosphere itself, but in some cases we may add some external substances like chlorine or ammonium chloride is another example for that. So we can add some external agents which are called as oxidizers for the burning process to occur, and they are called as oxidizers. So these three, that is fuel, then next one input heat, and oxygen. These three makes a fire triangle. Now, if we add one more element, then we will get another geometric structure, which is a fire tetrahedron. And the fourth element is the chain reaction or ignition continuity. So, chain reaction or ignition continuity, it is a thermal feedback from the fire to the fuel. We know that for a flaming combustion to take place or for the continuation of the chain reaction, there should be some thermal feedback from the fire to the fuel. So for the continuation of that combustion, there should be ignition continuity or chain reaction. And there are different methods of heat transfer. The first one is conduction, second one is convection, and the third one is radiation. So these four are the methods of heat transfer from one to other. uh, Conduction is the method of transfer of heat from a solid to another solid. It is a transfer of heat by direct contact through a solid body. For example, if a hot stove is there, heat is conducted through the pot to its contents. We know that wood is ordinarily a poor conductor of heat, but for metals, they are good conductors. So conduction, basically, it is the conduction of heat by direct contact through a solid body. But when we comes to convection, it is a transfer of heat caused by changes in density of liquids and gases. And it is the most common method of heat transfer. When liquids or gases are heated, they become less dense and will expand and rise. So convection is caused by the change in density of liquids and gases. And the third one is radiation. Radiation is the transfer of heat by infrared radiation or the heat waves, and it is not visible to the naked eye. And the third one is direct flame contact. Direct flame contact is the combination of the two basic methods of heat transfer, that is convection and radiation. Okay, and as hot gases from the fire scene or the flame rise into contact with additional fuel, the heat is transferred to the fuel by convection and radiation. until the additional fuel begins to vaporize. So that is the fourth method of heat transfer. So for the ignition reaction to continue, this four reaction or through this four processes it can continue. So these four elements will make a fire tetrahedron. In the fire triangle, there are only three elements, that is fuel, oxygen and heat energy or input heat. And the fire tetrahedron, it have oxygen, heat, fuel and a chain reaction. And now we have to look into accelerants and incendiary devices. So accelerants, these are the materials which are added to start or sustain fire. So some of the materials can't burn by themselves. We have to add some external materials to make them burn. So such substances that we add externally to start a fire or to sustain a burning process are called as accelerants. For example, gasoline, kerosene or paint thinners like that. And incendiary devices. Incendiary devices are any materials, substances, device, or a combination thereof which is capable of supplying the initial ignition and of fuel for a fire and is designed to be used as instrument of willful destruction. For example, cooking equipment, hair dryers, like that. So they will supply the initial ignition and they cause the ignition or they will cause the fire to begin. So these are incendiary devices. Now we are going to discuss about the stages of a fire. Actually, there are four stages in a fire. The first one is the incipient stage. Incipient stage is the first stage or the beginning stage. It is the first stage where ignition has occurred, but there has been no spread. So the fire just started, but the spread haven't started yet. So that is the incipient stage. The second stage is the growth stage. During the growth stage, the fire is self-sustaining. The third stage is fully developed stage. That is the fire as is at its hottest point and burning all its available fuels. The fourth one is decay. Decay, or it is the last stage. Fire is running out of fuel, but is still very dangerous. This is the longest stage. So this is an overview of the stages of fire. But if we look up close into what is a room fire sequence, then we have to discuss all these in detail. So during a, if you are investigating a room fire, or if a fire is confined to a room or a space or a defined space, we have to identify the stages of fire. So the first one is incipient stage, or it is the growth stage. So during the first stage, the fire is in its beginning stage. That's the flames are localized here, and the fire is fuel regulated. That is, the intensity of fire is solely depending upon the availability of the fuel itself, or the configuration, the mass, geometry of the fuel only, and it will not depend upon the availability of oxygen. Okay, the important point that you have to ponder here is the fire at this stage is depending upon the availability of fuel only. Okay, the flames are localized, and many kinds of patterns like V patterns on vertical surfaces can be seen in this stage. We will discuss about the patterns in the next slides. So first stage is the incipient stage, that is the growth stage. The next stage is the free burning stage or the developmental stage. So during the developmental stage or the free burning stage, the fire is intensifying. Okay, the intensity of fire is increasing in an alarming pace. So it is the free burning stage. The more fuel is being consumed at this stage, and the intensity of the fire is increasing, and the flames will spread upward and outward from the initial point by many means like conduction, convection, direct flame contact, like that. And there's a chance for rollover to occur. Rollover occurs when ignition of the upper layer results in fire extending across the compartment at its upper levels. So there's a chance for occurrence of rollover during the second stage of this room fire sequence. And fuel, this stage also is fuel regulated. Oxygen has no role in the second stage also. The fire in this stage is solely fuel regulated, and there's a chance for flashover in this stage. So what is flashover? Flashover is an important concept. So It is during the second stage, that is free burning stage, flashover will occur. So flashover is if the when the upper layer of the room reaches a temperature of approximately 1100 Fahrenheit, sufficient heat is generated to cause simultaneous ignition of all the fuels in the room. Okay, so this is called as flashover. That is when the upper layer of the room reaches a temperature of approximately 1100 Fahrenheit, all the contents of the room will ignite simultaneously, and this is known as flashover. Okay, so once flashover has occurred, then survival is impossible. Okay, so flashover is the simultaneous burning of all the contents of the room, and it will occur during the second stage, that is the free burning stage. And the third stage is smoldering stage or the decay stage. It is the last stage in the room fire sequence. So smoldering stage or decay stage, in this stage fire is oxygen regulated. That is, the first two stages were depending upon the configuration, mass and availability of fuel, but the last stage is depending upon the availability of oxygen. So backdraft may occur if source of oxygen is introduced. Okay, smoldering stage is also called as um, uh, decay stage. So smoldering stage, there is a fuels are almost burned, and the fire is solely oxygen regulated. So during the firefighting, if the firefighters are introducing some amount of oxygen, then there is a chance for simultaneous burning. Okay, so at this stage, backdraft or the occurrence of backdraft, or there's a chance for occurrence of backdraft at this stage. So this is the smoldering stage or the decay stage. So these are the three stages of room fire. First one is the incipient stage, the second one is free burning stage, and the third one is smoldering stage. And now let's discuss about arson investigation. So as we have got a basic idea about the chemistry and physics of fire and the sequences involved during a fire occurring in a confined space, now we have to look deep into arson investigation. So as arson investigators, first we have to get a basic idea about what we are investigating for, or what the objectives, what are the objectives of arson investigation. So the first objective is to determine the nature of fire. So we have to determine the nature, that is how the fire has occurred, or whether it is accidental, or it is natural, or it is arson. So we have to find the nature of fire. The second one is to find out the cause of fire. Third one, to find out the origin of fire. So finding the origin is very important during arson investigation. Then to analyze the evidence, which indicate whether it is arson, spontaneous or accidental fire. Then we have to link the culprit with the fire. There will be one culprit who has caused the fire, and we have to link them. We have to link the culprit to the fire. Then to establish the extent of damage, we have to calculate, or we have to establish the extent of damage that the fire has caused. Then to find out the evidence of other crimes, if any. So if the culprit has used fire to destroy the evidence of other crimes, we have to find the evidences of other crimes, if there is any. Then to ascertain the modus operandi. Modus operandi is the mode of operation. So we have to find the mode of operation. So these are the aims or objectives of an arson investigator. So, in a systematic collection of clues in a case of fire, one should, or an investigator should follow these instructions or these things during the investigation procedure. The first one is guard the scene of occurrence till the examination is complete. So, we know that securing the scene or cordoning the scene is very important during the investigation process, whether it is arson or if any for any kind of crime scene, we have to guard the scene of occurrence. Then the next is check for any visible victims and any witness or bystanders. We have to collect some important data from the witnesses or bystanders, because by observing the color of the flame or the duration of the flame, we can get some important data regarding the nature of fire. So we have to check for any visible victims and witnesses or bystanders. Then documenting the scene by taking notes. Documentation is an important step in all crime scenes. So we have to document the scene by taking notes. Then photographing and videography. Photography and videography is also very important. So taking photographs and videos of the scene should be taken from different angles. Then we have to collect the copy of the site and building plan. For investigation process to occur in a precise manner, we have to collect the copy of the site and building plan. Then take the list of stores from the occupant. So from the owners or from the occupant, we have to collect some important data regarding the structure or the construction of the building. Then collect evidences properly without contamination. So we have to prevent the contamination in all possible manners during the investigation process. So collect evidences properly without causing any damage or contamination to the evidences. We will discuss about these in detail. That is collection and packaging. We have to discuss in detail when it comes to an arson scene. So collect the evidences properly without causing damage and contamination to the evidences. And fourth one is packing suitable containers and transport to laboratory. So for packaging evidences, each and all that every evidence has their own method of packaging. So for arson or for ignitable liquid residues that we call as ILRs, for the evidences that we collect from an arson scene, we have to pack them in separate cans or separate evidence bags. That also we will discuss in coming slides. Now we have to look into indicators of arson. So, when we are investigating an arson scene, there will be some indicators which will suggest the fire scene is an arson. So, we have to look in close about the indicators. So, the first one is multiple point of origin. So, multiple point of origin means there will be some unconnected, separate, independent fires. That is, more than one point of origin will be there. So each fire will be independent of other. I am discussing about the indicators of arson. If the scene is arson, then we can see this indicators. So the first one is multiple point of origin or multiple um, points. Where the fire point of origin means the point where the fire has occurred or originated. So there will be some unconnected, separate, independent fires. And the investigator must establish that these multiple fires are separate and unconnected, and there is no accidental or natural cause could produce these fires. So if there is unconnected, separate, or independent fires, that will suggest or indicate that the scene is an arson. The next one is presence of trailers. Trailers can be any combustible or flammable material used to spread fire from one point to another, and they always leave char or burn patterns on surfaces where they are used. So these are the substances. These are combustible or flammable materials which are used to spread fire from one point to other point. And if these substances are used, then they will leave char patterns or burn patterns on the surfaces where they are used. Actually, there are two types of trailers. They can be class A trailers or class B trailers that I haven't mentioned in the PPT. But actually, there are two kinds. First one can be class A. Class A, like newspapers, candles, clothes, like that. That is solid materials. Solid combustible materials comes in class A. Then class B combustibles are there. Class B combustibles, like examples are any kind of kerosene, gasoline, alcohol, etc. are examples for class B trailers. So if there is presence of trailers, then it also indicates that the scene is an arson scene. The third one is presence of liquid accelerants. So we have mentioned that what are accelerants? So liquid accelerants are used to start and sustain a fire. So if these kinds of accelerants are present in unusual areas where usually they would not be normally found, then it suggests incendiaries. So when these kinds of liquid accelerants are seen and their presence is not justified by the owners of the room, then we have to look deep into it or we have to investigate deep into it. The investigator can proceed with the investigation using this information as the indicator that the accelerant were introduced by another person and that this fire may be of incendiary origin. So if there is presence of liquid accelerants which can't be justified by the owners or the persons present at the room, then the investigators have to deal in detail with these kinds of evidences. The fourth one is removal or substitution of contents prior to fire. So some of the criminals may remove some expensive objects or some antique objects or the items of sentimental value from the scene. So if the this kinds of properties are removed or substituted from the fire scene prior to the setting of the fire, this may indicate that the person willfully cause destruction to the room. So some of the criminals may use or there's a chance for removing wedding or family photo albums or any kind of jewelry, television, VCR, CD players from the room. So if these kinds of expensive objects or items of sentimental values have been removed from the room, then it suggests of incendiarism. The fifth one is fire at unusual location. So if fire is seen in a location where um, it is not usually found, or if there is no chance for finding such a fire in that scene, then it also is a indicator for this arson. So fire at areas with no identifiable heat source is also an indicator of arson. The sixth one is evidence of other crimes. So a fire may have been set to cover the evidences of other crimes such as murder, burglary, embezzlement, tax fraud, etc. As we have discussed earlier, some criminals may use fire to destroy the evidences of other crimes. So, if there is such kinds of evidences, like evidences from murder, burglary, embezzlement, or any other kinds of crime, this is also an indicator. So, these are the indicators of incendiarism or indicators of arson. Now, the next is establishing origin of fire. So, when we are investigating an arson scene, we have to the first aim or the first objective of an investigator is to establish the point of origin or the origin of fire. So first we have to apply the backwards theory. That is the theory that brings or that lead a investigator forward is the backwards theory. Backwards theory suggests that the investigation should proceed in a exterior to interior manner or from the least damaged area to the most damaged areas. So most likely to be located closest to the lowest point that shows the most intense characteristics of burning. So the investigation should be proceeded from the exterior of the crime scene to the interior and from the least damaged areas, the areas where there is damage to the damage in uh, minimum damage to the area where there is a extreme damage or to the most damaged area. So during investigating we have to follow this backwards theory. Then depth of char. So charring usually occurs at the deepest, at the point of origin. So the depth of char, we have to find the depth of char, and this char patterns always help to identify the point of origin. For example, char pattern on a door will help the investigator to determine which side of the door the fire was on. So, if the char is present on one side, we can conclude that okay, it was from this side or it is in this side that fire has occurred. So, char pattern will help us to determine from which side of the door the fire was on. Then char pattern on a floor would help the investigator to determine the use of accelerant and its path. So if there is char patterns in the floor, then or there may be char patterns from trailers. So such kind of patterns will help us to determine the use of accelerants or trailers. Then we have to inspect the electrical installations, heating appliances, burned materials like that. So if there is short circuit, overloading, jury rigging like that, the investigator should inspect this all materials in detail. Then collect the information about the character of the fire. That is, the character of the fire can be the details about the character can be collected from a person who have witnessed at the fire scene. So we have to conduct a witness interview in detail and collect the information about the character of the fire, like the color of the flame, the duration of the fire, like that, and the methods that used to distinguish the fire. So we have to collect all these details in details from the witnesses or from the bystanders. Next, ascertain the time when fire started and when it was extinguished. Then ascertaining the mode of extinguishing the fire, then collection of fingerprints, it's very important. There's a chance for occurrence of fingerprints from the crime scene, like in the point of entry and in the point of exit. There's a chance for leaving fingerprints by the culprit. So we have to collect these kinds of other evidences like fingerprints from the scene, like the possible sites where we can see fingerprints are point of entry and exit, door handles, window panes, like that. So we have to carefully check these points and collect fingerprints if they are present there. Then check for trace marks, that is tool marks, footprints, tire marks, etc. So there's a chance for occurrence of this kinds of tool marks, footprints, tire marks, etc. in the scene. So there should be a detailed analysis of all these kinds of evidences. Then the culprit may have used some initiators. So these initiators should also be checked thoroughly. That is the unconsumed parts of initiators forms useful clues. So if there is some of the parts of the initiators, they may serve as some clues for our investigation. So they found at the point of initiation of the fire, they are actually located. So we have to look into detail, or we have to check them in a detail. That is the unconsumed part of this initiator should be examined detailedly. Then accelerants, as we have mentioned, accelerants we have to check the presence of any residues, that is ILR, ignitable liquid residues. We have to look for ILRs. Then foreign matters, there's a chance for occurrence of foreign matters in the crime scene. So we have to look in close to the foreign matters present in the crime scene. Then electrical installations. Next one is fire extinguishing devices. So some criminals may tamper the fire extinguishing devices. An arsonist usually tampers this kinds of devices. So if they are found damaged, the malicious intent can be established. So we have to um, examine in detail about the fire extinguishing devices if they are present in the crime scene. Then evidences of other crimes. So if there are any other kinds of evidences, then we should check them in detail too. So the debris that we collect from the crime scene should be carefully checked for the evidences of some other crimes, like if murder, fraud, theft, or robbery. If such crimes have been happened, we have to check in detail whether such kinds of evidences from that crimes is there or not. So the premises may also may have been used for illegal activities like counterfeiting currency, or like secret press, like that. So if there is any such kinds of evidences, we have to collect them too. The next is color of smoke. So the color of smoke indicates it indicates what type of materials was burning. So we have to check for the color of the smoke. Then the color of flames. The color of flames always indicates at what temperature the fire was burning. So examining the smoke color or color of the flame, these details can be collected from the witnesses or from the bystanders. So color of flame and color of smoke will give us valuable insights of the type of material burning and temperature of the fire during the burning process. Then order of the burning material. So if we check for the order of the material, it also serves as a clue for identifying whether it was arson, natural, accidental, or the type of material that is burning, like that. So this all will serve as important clues for leading an investigator forward. Now we have to discuss about some fire patterns that are usually found in an arson scene. The first one is U-shaped pattern. Hello. Hello, am I
Ma'am,
audible?
ma'am, you can continue with the session.
Okay, okay, fine. So the investigator should um, now check the fire patterns present in the scene, because these fire patterns will serve as the clues, or will give some information about the cause of fire or the origin of fire. So the first pattern is U-shaped pattern. So U-shaped patterns are created by the effects of radiant heat energy on the vertical surfaces such as wall. Um, in the vertical surfaces such as wall, we can see this kinds of patterns, and these kinds of patterns are mainly formed by ignition occurred while cooking or frying, reaching the ignition temperature, and it is closely related to human errors. Okay, so from cooking oil ignition and growth, the fire plume caused its upward current to create a U-shaped pattern in the stage of pre-flashover. So during the flashover stage, there's a chance for occurrence of this kinds of patterns. So it is mainly formed by ignition occurred while mainly cooking or frying, reaching the ignition temperature, and it may suggest that, or it will give us valuable clues regarding the uh, processes that have been occurred in the pre-flashover stage. The next one is inverted cone pattern. So inverted cone patterns are commonly caused by the vertical flame plumes of the burning volatile fuels not reaching the ceiling. So it may look like an inverted cone. So that's why the name inverted cone pattern. And they are characterized by relatively short-lived fires and low fires that do not fully evolve into floor-to-ceiling flame plumes or flame plumes that are not vertically restricted by ceilings. So this kinds of patterns is also a important clue that we have to check for when we are investigating a scene. The next one, or the important pattern, is V pattern. So the V pattern is a common fire pattern. It will be in a V shape. Okay, it can be seen on vertical surfaces, and the lateral spread. Okay, as the arms of the V is suggest the lateral spread of the fire. And if we are tracing the V into back, the corner point or the that apex or the uh, when we trace it back, we can trace the or we can find the point of origin. So the lateral spread of the sides of these patterns are caused by radiant heat from above and by the upward and outward movement of flames and hot fire gases when they encounter a horizontal surface such as ceiling, a tabletop, or a shelf. So these kinds of patterns can be commonly seen in arson scenes. The angled lines that produce the V can often be traced back toward the point of origin. So the angled lines is traced back. Their apex indicates the point of origin. The fourth one is pore pattern. Pore pattern is it's very common in scenes where the accelerants have been used. So the pore pattern by liquid accelerant is the typical burn pattern identified in the arson fire scene. So during burn test, paint thinners have been poured on the floor and wooden chairs in this compartment. So when we use some kinds of liquid accelerants, there's a chance for occurrence, or there is a chance for leaving this kinds of pore patterns in the floor or in the substances which are present in the crime scene. The fifth one is alligator char pattern. So as the name indicates, alligator char pattern means the patterns which are like the scales in an alligator. So as the burning continues and more volatiles are driven out of the wood, the char layer becomes deeper and splits and cracks are formed in the charred surface, and that will resemble as to the scales or the skin of an alligator, and that's why the name alligator char pattern. In some case, alligator's pattern was caused by the rapid intense movement of heat and flame, and this condition may be associated with the use of an accelerant. So if there is a presence of alligator char pattern, it may be associated, it may or may not, but it usually is associated with the use of an accelerant. And the sixth pattern is heat shadowing. So heat shadowing results from an object blocking the travel of radiated heat, convected heat, or direct flame impeachment. That is when the heat is transferring from one substance to other, then there's a chance for blocking that heat. So when a substance block the heat from its traveling, then this kinds of there's a chance for producing this heat shadowing pattern. So conducted heat does not produce this kinds of heat shadowing, but convected heat, direct flame contact, or radiated heat always um, leaves a heat shadowing. And this heat shadowing is very helpful for the investigators for reconstructing the scene. The next pattern is circular patterns. So circular patterns are common at fire scenes, and they are generally they generally represent areas which were protected from burning by circular items. If in the crime scene, if waste baskets or the bottoms of pieces of furniture which are in circular shape is present, then such kinds of substances will leave a circular pattern on the floor. So this kinds of patterns will give us some clues regarding the origin of fire or whether an accelerant was used or not, like that. So now let's discuss about the collection, preservation, and packaging of evidences. So meticulous effort should be employed for the collection, preservation, and packaging of evidences from a arson scene. So first, 2 or 3 quarts of ash and soot debris must be collected at the point of origin. Then the collection should include all the porous materials and all the substances thought likely contain flammable residues. That is, in the crime scene, there may be some porous materials like wood floorings, upholstery, rags, or any other kinds of substances, porous materials like that. So there is a chance for absorbing the accelerants by them. So that those kinds of substances should be collected. Then the fluids found in open bottles or cans must be collected and sealed. Even such containers appear to be empty. We have to check in detail about these, and we have to collect them and seal them. Then collect and store the evidence in closed and sealed airtight containers. We have to use airtight containers here, and the common containers that we use for collecting the evidences from an arson scene are metal cans, wide mouth glass jars, or special evidence bags. So, this is an important point. That is, we always use metal cans, wide mouth glass jars, or special evidence bags for collecting evidences from an arson scene. Or new clean paint cans with friction lids are also good containers because they are of low cost, they are airtight, they are unbreakable, and they are available in variety of sizes. So we can use new clean paint cans also. So the mostly used containers for collecting the residues from the evidences from an arson scene are metal cans, wide mouth glass jars, or special evidence bags, or we can use clean paint cans also. So the cans and jars should be filled one half to 2/3 full, leaving an airspace in the container above the debris. The investigators should keep in mind to leave some space above the collected debris. Then large bulky samples should be cut to size at the scene as needed, so they will fit into the available containers. So if we are collecting the large or bulky samples, they have to be cut into small pieces before collecting them and packaging. Then plastic polythene bags are not suitable for packaging specimens because they react with hydrocarbons and they permit volatile hydrocarbons vapor to be depleted. So plastic polythene bags are not suitable for collecting the evidences from an arson scene because there's a chance for reacting this hydrocarbons with this, and they will permit the volatile hydrocarbon vapors to be depleted. So these kinds of bags are not used for packaging evidences. And the other point that we have to consider here is to collect the control material, that is the exemplars. The uncontaminated control specimens also should be collected from the crime scene or from an area which is from the vicinity of the crime scene. So the next is laboratory examination. So after we collect the evidences, after we package and when it gets into lab, we have to examine them in detail. So when the evidences are submitted into the laboratory, first of all, we have to extract the evidences, or we have to extract the ignitable liquid residues from the uh, debris that we have collected from the arson scene. So we may use different kinds of procedures or processes for this extraction process. So we can use flotation process, steam distillation, solvent extraction, solvent flushing, vacuum distillation, overhead spacing sampling. These all are some of the methods that we will employ for the extraction of evidences. These are some of the techniques that we use for extraction process. And after that, when the evidence we get evidence in the lab, we have to use some instruments, or there are some instruments that we prefer for identifying the accelerant or the materials that have been used in the scene. So the mostly common instruments that we employ during the investigation or for the analysis of the evidences are, first one is GC, that is gas chromatography. Then GCMS, gas chromatography mass spectroscopy, we can employ. Then atomic absorption spectrophotometer, that is AAS. We can use this also. Then HPLC, that is high performance liquid chromatography. So these are some of the common instruments that we use in laboratory for the analysis of the evidences that we get from an arson scene. So this was this is some basics about arson and the investigation. So as our time has come to an end, I'm not delving deep into these concepts. So let me conclude my session.
Thank you for such an enlightening and thought-provoking session, ma'am. Your insight have truly broadened our understanding on this ASEAN topic. Now, let's move on to the Q&A session. Participants, you can address your queries in chat box. Ma'am, they want to elaborate about the extraction methods.
Hello.
Yes, ma'am.
Yeah, extraction process. Right. Am I audible?
Yes, ma'am.
Okay. Okay, we can use different kinds of extraction process. That is for uh, there may be some presence of ignitable liquid residues in the debris that we collect from a arson crime scene. So the most common types of extraction processes that we use in laboratory are, there is flotation process, steam distillation, then solvent extraction. These all are some methods, and this all have their own principles and procedures. Okay, I think I will share the PPT. So I have in the detailed notes about this all, and if you need, I will provide the materials for that. So if we discuss them all in detail, I think it will consume some more time. So it will be convenient for you if I share my notes, right?
Yes, ma'am. Thank you, ma'am. Today we are concluding our session. I would like to extend my heartfelt gratitude to ma'am for sharing us in expertise, and it was very an inspiring session, ma'am. Session is over to you, ma'am. Thank you.
Okay, I appreciate all of your engagement and attention, and thank you all. Thank you.
Thank you, ma'am.
I would like to thank all the participants for their enthusiastic and their active engagement. Let us continue to explore, learn, and grow together in the field of forensic science. Thank you, guys.
Thank you, ma'am.
Thank you, ma'am, for this session.
Thank you, ma'am.